Okay, good afternoon, everyone. So my name is Stephen Trong. I think I want to start first with mention that we are more like on applied science rather than purely research. And we start with one intern, which is the first guy, Jianshu, but he couldn't come here today. And I also want to take the opportunity to thank Christina for the time she working with us as a scientific advisor. Last but not least, of the person in the in the list is Jiang Fong. Thank you. So this is the flow of our outline today. So we start with the overview, and then we go through the problem statement, challenges, and our approach. We will spend more time on architecture and also on the experiment evaluation and analysis, and then our conclusion. So first, grammatical error correction. The GEC purpose is to correct the local errors in the word order, while at the local error, we want to correct in terms of spelling and inflection. The motivation that we recognize so far is the recent neural network, the NMT, have substantially improving over the phrase-based machine translation. However, I think it's a constraint of lack of the optimization in the GEC when it's been applied. So the proposal architecture we come up with is with the outcome that we outperform the previous neural network with the 45.15 score compared to the previous model based on the Cornell 14 data set. So in terms of the problem space, as you know that the GEC is basically cast the problem as a machine translation. And I think the translation is happened in the ungrammatical English sentence to the correct ones based on the Gao paper in 2010, and also have been proving superior to the system based on the local classifier with Rosso, Karya, and Groth. However, the specific challenge with the MT approach, mainly one is extreme large vocabulary needed, and especially with the large number of words in languages, and also is corresponding alteration. The second part of this is to deal with the capture of the different level of information for different kind of error. Particularly, like for example, like misspell and local grammar correction, you need to capture the word level and sub-level information. And also in the word order or like the usage, you also have to have global semantic information that you need to capture. So the related work in this area so far is basically in the NMT. Basically, like I mentioned earlier, is substantial improvement on terms of the quality based on the phase-based MT before. And the fundamental of the NMT is about like basically sequence-to-sequence model, as you all already know, and restrict the vocabulary by the high frequent word, high frequent. And in the GEC task, Sakaguchi also emphasized that the importance of the long distance or the knowledge of the word dependencies is super important to solving the problem on GEC. However, the neural approach to the GEC is kind of like less explored. We noticed two prior works so far. One is a word level sequence to sequence that's done by Yuan and Bisco. However, I think the approach is kind of like failed to get like the information account for the OOV case, the alpha vocabulary, as well as the generalization of the approach is kind of like limited for unseen words. The second approach is on the character-based sequence-to-sequence by Xia in 2016. And the constraint of that is in terms of effective, like getting the world level knowledge information. So here we come with our approach. Basically, we propose a novel hybrid neural network with attention netted layer. So the approach is solving the large amount of vocabulary, especially in the OOV case. And what we do is we bring all of the, contextual word into the representation of unified vector, including its context. And the second is we also capture the different level of information for different types. The word level information is used to correct the global grammar and fluency error. And while the character information is used for correcting, local error in terms of misspell or inflected error. And the approach that we did is two things that we propose in here. One is the hybrid architecture, overcome the loss of information in the word level. And what we do is compose on the presentation of the OOV words using the character ANN model. The second novel idea what we have is basically is a nested level of attention architecture so that we can address the problem in a GEC task. Particular is in terms of that like many small number of local edits to the character sequence of the source word corresponding to the target OOV word. And second is the character level attention provide the decoded information so that you can access the relevant source of character sequence. So our architecture is combined of the both, and particular is the attention for character level. So the experiment that come with what we did is we leveraging 3 data sets from the NUCO and also from the Cambridge Learning Corpus, the CLC, as well as Language Aids. And we also using the shared task data on the Cornell 13 for lab test set and also Cornell 14 for the test set. And we follow basically the matrix, which is F0.5 score. And what we did is we compared to 2 cases. One is a pure model compared to the word NMT plus the unknown replacement as a baseline. And in this model, basically the unknown replacement is a post-processor for the NMT. And then on the hybrid model, which is already applied in the machine translation, inspired by Leung and Manning, is basically we do the hybrid model with a single word level of tension. And then also we compare with the iterated model with the language model. That's done by, say, So we cannot like publish a paper without a number, right? So this is our result. So based on the comparison, our like proposal nested attention hybrid model, we got like basically for the PU model we got 41.53, and also in the iterated with web scale language model we got 45.15. So let's go into the analysis of how we can achieve that, score. So first, we're taking the data set and we divide it into OOV and non-OOV case. And what we find out is basically our model is have a fairly big improvement in terms of OOV. And if you look at the sample, right, I mean like the model able to correct it into the as the golden set. And when you take that OOV case, which is we show it by hybrid model, we also divide into smaller change and larger change. So here's a definition of what we define from the ADIC term in the small change compared to large change. So, so in the sample you see in front of you, they have two ADICs. And this is basically based on the saw and target phrase of ADIC with orthographical similarity or not. Then we just generate basically Kaplan definition, a rule base to separate between the small change and large change. With like basically we got like 39% for the small change, and the rest is just a large change. So from the analysis, we saw that like the proposal we have with a nested attention hybrid model, we got in the small set is a really large improvement, both from precision and recall. And a small increase in the precision for the large change, and a small negative for the recall. So this leads us to the conclusion that our model is basically able to solve the unique challenges of the GEC task, and by basically bringing both the global world level and local character level into a unified way. And that result, it generated substantial improvement that we got so far for correcting confusion with the rare or orthographical similar words. Yeah. So that's conclude our talk. So that's next for, thank you for attention here, and also next for Q&A.
Okay, so we have a couple minutes for questions.
Hi, thank you for the talk. This is Joel Techo from Grammarly. I have a question on your evaluation. So your training data, you're using Knuckle, Lang8, and CLC. Did you try evaluating it with only Knuckle or only Knuckle plus Lang8?
Can you repeat the last?
Did you try a training solely on Knuckle or solely on Knuckle plus Lang8? Just leave out the CLC part.
Just the latter one.
Yeah, did you try training on simply the Knuckle corpus and then evaluating?
So we do is with the evaluation, not on the alteration. So let me bring it here. So
yeah, I guess my point is that I'm not sure whether your high performance comparing to the other neural models is due to your model or due to the vast amount of training data that you're using in comparison to the prior work. So Xie et al. 2016, I believe, used 1, I think 3, and maybe some artificial errors. but the CLC is like really, really massive. And so I wonder if you take that out, do you still have an improvement over the prior state of the art?
So the way we do is basically we compare, we have a baseline like I mentioned, and then we're using the same set that we evaluate based on like, the Cornell like share task standard.
Okay, well, maybe I'll talk to you afterwards. Yeah.
Yeah, actually, we try build our baseline. To catch up with the best number at that time. So we try different experiment of using different kind of the training data. So we find out that the combination of these three data is the best. And then for the hybrid experiment and also the nested experiment, we all use the same training data.
Okay, but it's still a lot larger than everybody else previously I used. That's my point.
Yeah, thank you.
Yeah.
So we have time for one more question. I know I saw several hands up a minute ago. Now
I think the model is working on sentence by sentence. What about you need to merge two sentences, or what about one sentence is going to split into two sentences? Did you have, did you do anything with that kind of scenario?
So what we did is basically for the alteration, we do sentence to sentence as a pair for the, validation.
Yeah, my question is sometimes you need to split one sentence into two sentences. Sometimes you need to merge two sentences into one sentences, so that source sentence is two, target is just one. Sometimes it's vice versa. Did you have this kind of scenario? Did you deal with this kind of scenario, or your model is able to deal with this kind of scenario? That's my first question.
So that's a good question. I think right now we try basically based on the pairs of sentence to sentence. Yes.
Okay. Okay.
Yeah.
What about paragraph level information? Say one sentence is talking about a subject in sentence 1, but you need that information in sentence 5. Is the model is considering sentence 1 while it's working on sentence 5?
No, we don't do that right now. We don't do that.
Okay, thank you.
Yeah,
nice work.